Okay, we are continuing a lesson 11.2 with Explore Activity 3, Exterior Angles and Remote Interior Angles. An interior angle of a triangle is formed by two sides of a triangle. So, I'll give you a little illustration here, right? These are our interior angles. 1, because it's formed by two sides. 2, formed by two sides. And 3, because it's formed by two sides. So those are our interior angles. An interior angle of a triangle is formed by two sides of the triangle. An exterior angle is formed by one side of the triangle and an extension of the adjacent side. Adjacent means next to. So an exterior angle would be this one right here. It's formed by one side and an extension from the adjacent side. So this would be our exterior angle. Each exterior angle has two remote interior angles. A remote interior angle is an interior angle that is not adjacent to the exterior angle. Okay? So our remote exterior angles for this one would be 2 and 1, because our exterior angle here is 4. They are two angles that are not adjacent, right? That would be this one, but are inside the triangle. So that would be 1 and 2 for our exterior angle 4, and then it just bullets all of those right here. I'll just color code those. 2. And there we go. Okay, so what we're going to do is we're going to now take a look at the special relationship between the measure of an exterior angle and the measure of its remote interior angles. Okay? So what we're going to do, as A is asking us to do, is extend the base of the triangle and label the exterior angle as angle 4. So we're going to extend this angle and name this angle 4. Done. The Triangle Sum Theorem states that the measure of angle 1, the measure of angle 2, and the measure of angle 3, the sum of these angles, they're inside a triangle, should all equal 180 degrees. They are all supplementary, right? The measure of angle 3 and angle 4 form a linear pair or straight angle. We're going to call this a straight angle. Okay? That means that the sum of these two form a straight angle, which is 180 degrees. So the measure of angle 3 and the measure of angle 4 are 180 degrees. So far, so good. We've got our exterior angle formed by a side and an extension of the adjacent side. We've got the sum of 3 and 4 to equal 180 degrees and be a straight angle. So we're going to use the equations in B and C to complete the following equation. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 should be equal to, right, these all equal 180, and should be equal to the measure of angle 3 plus the measure of angle 4, because these lie on a straight line, which make them a straight angle, and they should be 180 degrees. So 1, 2, and 3 equal 180. We know that because the sum of all interior angles of a triangle are 180. And we also know that the measure of angle 3 and angle 4 equal 180 because they lie on a straight angle. So use the properties of equality to simplify the equation in D. So how would we simplify that? We could say, well, these both equal 180, right? The measure of angle 3 does not change, so we can actually eliminate that, right? So we're going to eliminate that. Because if we were to write this like an equation, we would subtract from one side, add to the other, and it would cancel out. Or, yeah, subtract, and it would cancel out. So then what we end up with is the measure of angle 1 plus the measure of angle 2 are equal to the measure of angle 4. And so if you're visual, what that means is that these two angles combined, 1 and 2, should be the same as the measure of angle 4, because they are both less the measure of angle 3 from 180, right? 1, 2, 3 equals 180, 3 and 4 equals 180, so 2, 1, angle 2 and 1 should be equal to angle 4. So we're going to kind of play that out a little bit. So what this states is the exterior angle theorem states that the measure of an exterior angle is equal to the sum of its, what did we call those? Remote. And we call them remote because they're far away. Interior because they are inside the triangle angles. So that we call these remote interior angles. So the sum of the remote interior angles is equal to the measure of the exterior one. So we're going to reflect. Sketch a triangle and draw all of its exterior angles. How many exterior angles does a triangle have at each vertex? Okay, well, let's sketch a triangle. So here's my triangle. And then I create exterior angles by extending, right? So this would be one side and an extension of the adjacent, so that would be 1. This one includes one side and an extension of the adjacent, so that would be 2. I'm going to do the same thing over here. I'm going to extend this. So I've got one side and an extension, that would be 3. I've got one side of the triangle and an extension, that would be 4. Then I'm going to do the same thing here. I've got one side and an extension, that would be 5. And then I've got this side and an extension of the adjacent side, and that would be 6. So I have 6 exterior angles. So each vertex, each corner of the triangle has how many? Each vertex has 2. How many total exterior angles does this triangle have? Well, we just counted that up. That is 6. Okay? So let's go ahead and see what it wants us to do next. So it's using the exterior angle theorem. You can use the exterior angle theorem to find the measure of the interior angles of a triangle. Okay? So we're going to be making some equations here. So in this example, what it gives us is it gives us the measure of angle A, the measure of angle B, and the measure of the exterior angle of the triangle. Okay? So the measure of angle ACD. Now we know from just what we just did in our Explore activity that this angle plus this angle should equal this angle, right? So we can set up an equation where we have 3y plus 4y minus 4 equals 52 because the sums should be the same. So that's what they did here. They substituted that information in. 4y minus 4 plus 3y equals 52. So they combined like terms. They got 7y minus 4 equals 52. They used inverse operations, added 4 degrees to both sides. Then they had 7y remaining equals 56 degrees. They divided by 7. And they got 56 divided by 7 is 8. So y equals 8. So now you got to plug that value back in, right? So they plugged it back in. The measure of angle A is 4y minus 4. So they plugged in 8. So they had, because that's what y equals. 4 times 8 is 32. Minus 4 is 28. So the measure of angle A is 28 degrees. Okay. They plugged in angle B, which is 3y. So did 3 times 8, which is 24. So this is 24 degrees. And then, what do we know about this missing measure here, angle C? It's going to tell us. I bet it, well, we actually don't even have to, it doesn't actually take us there, but let's just go ahead and extend this learning. Like it is here with our math talk, describe 2 ways to find the measure of angle ACB. ACB, that's this last interior angle here. Well, we know that the sum of all 3 of these should be 180. So 28 plus 24 plus the measure of angle ACD should equal 180 degrees. You can't hardly see that. Right? So 28 plus 24 is 52, plus the measure of angle ACD should equal 180, right? So then I've got, which I know, right? I knew that's from here. So then I'm going to subtract 52 from 180. And so I've got the measure of angle ACD equals 180 minus 52, which is what? Let's work it out here. 180 minus 52. Borrow 7, 10, 8, 2, 128 degrees. And then you can double check that because the sum of these two angles should also be 180 degrees. So instead of doing this, you could have just done, well, I know this is 52. I know 52 plus something has to be 180 because these two angles have to equal 180. So that should be 100. That's how I can solve that. Okay, so the last thing we're doing is the your turn for number 8. So we're going to find the angle measure of M and N when given the exterior angle of 146. So we're going to set this up just like we did they showed us in the example. We know that the sum of these two angles should equal this angle. So I've got 5y plus 3 plus 4y plus 8 should equal 146, right? I got that from here. So I'm going to combine my like terms. 5y and 4y is 9y plus 3 plus 8 is 11. And then I'm going to use inverse operations to solve for y. So I'm going to subtract 11. Got 9y equals 135. Then I'm going to divide by 9. I'm going to do that over here. 135 divided by 9 is 15. Okay. So y equals 15. So now I need to plug that back into one of these values, right? I know that these values should be they should add up to be the same number here, right? So I've got 5 times 15 plus 3. So 5 times 15 is 75 plus 3 is 78. So this angle is 78 degrees. And then I need to determine this angle right here, right? So I can do this two ways. I can figure, okay, well, I can find out this angle, which would be 180 minus 146, and then combine those to solve this one. Or I can also plug the value of y into that equation, or that expression. 4 times 15 plus 8. 4 times 15 is 60, plus 8 is 68. So this missing angle is 68 degrees. We could determine this angle, of course, by subtracting this measure from 180, and that would give us this because this is a straight angle. And so that's kind of what you're going to be doing in this assignment, is determining missing angle measures, either exterior, interior, using what we know about the measurements of the interior angles of triangles.